Okay, let's give this a try. Graphing systems of equations. So when you have a system, it means that you have two or more lines that you're trying to find where they share a space. So for example, up here when we see intersecting lines, you got three types of solutions you can get for systems of equations when there's just two equations that we're looking at. For now, that's what we're going to look at. So you can get it so we're looking for that intersection point there where two lines intersect at one distinct point. Okay, we can get two equations where they look a little different, but they're actually the same line, so they share an infinite amount of points. Every point on the line is shared. Or you can get two equations where there are no intersecting points, so you get no solutions out of it. All right, you can kind of see the little terms down here. We're going to concentrate on the mechanics of these as we go. All right, so I'm going to get right into it here, and let's try and solve a couple of these things by graphing. So let's see if I can put this up here, and trying to get this so I can, yep, that should work. Okay, so I'm just going to do a couple of quick examples here. All right, so let's take a look at number 1 here. And I'm just going to go ahead and graph these two lines. So y is equal to minus 2. Well, that's just the straight line that's horizontal through minus 2. And then I don't like the way this one looks particularly, so I'm going to turn it into y is equal to mx plus b form. So I'm going to add 3 to both sides. I'm going to subtract 3x from both sides. And then I'm going to divide by -1. So I end up with that line. So I guess if I'm going to use a y-intercept of 1, and then my slope here of that line is going to be 3 over 1. So I'm going to kind of make both of them negative, still positive 3, right? So I'm going to go down 3, 1, 2, 3, and over 1 to get my second point. And sure enough, there we can see that my solution for this system, okay, this system of two equations, is going to be this point right there. That is, whoops, let's put that on the other side so we don't confuse anybody. Okay, is going to be that system, solution to this system is going to be 1 and minus 2. So the point that the two lines share is the solution to the system. Let's take a look at another one here. So both of these lines are in kind of a standard form, so I'm going to go ahead and put both of them into y is equal to mx plus b. So in this case, I'm going to get y is equal to minus 2x plus 6. And in this one, okay, I'm going to take the y over to this side just to make it easier to kind of handle there. 2x plus 2, and now I can graph both. So for this first line, I'm going to have a y-intercept of 6, so 1, 2, 3, 4 is up here, and a slope of minus 2. So down 2 and over 1 would put me there. Okay, and I could keep going on with that little slope pattern, and I'll end up with this line, right? Okay, and here just for kicks, I'm going to make this one red. Okay, so I'm going to start at plus 2. And then my slope is 2 over 1, so I'm going to go up 2 over 1. So it looks like that spot right there would be the solution to my system. So that's going to be the point at 1 and looks like 1, 2, 3, 4. Okay, so you can get some, I guess, what you'd call stranger solutions. All right, so if I took a look at this example here, number 3, okay, well, let's do it the same way. Let's put it in y is equal to mx plus b form each one. So the top one, let's make black. And the bottom one we'll make red. Okay, so the black one there is going to turn out to be, well, let's do a couple of steps here. 2y is equal to minus 3x plus 6. And so y is equal to minus 3 halves x plus 3. So that looks like a plus 3 down 3 over 2. Hey. Okay, so I can finish my line off. That looks like, well, I guess it looks something like this. Let's go over to red here and do the other one. So I've got 2y equals minus 3x minus 4 and divide by 2 minus 3 over 2x minus 2. So I've got here as my y-intercept. And I'm going to go, well, let's go up 3. Oh, wait, what's going on here? Up 3. And minus 2 is there. Oh, that doesn't look right. Ha! I didn't do anything wrong. Take a look at this. So if I draw that line in there, do these lines ever cross? No. So this is going to be a no solutions type of graph. Let's look at the next one here, just to finish this off, number 4. And so again, it looks like we got two completely different graphs here, but if we change the first one into y is equal to mx plus b, I can go and divide everything by 2 here, and I'm going to get y is equal to minus 2x plus 2. And then check it out. Line number 1 is the same as line number 2. So I'm going to get this picture, plus 2, and then a slope of minus 2. And if I go ahead and graph the other line on top of that, it's the same line. So here, each of the lines, well, here, let's do it in red too. This is the other line, isn't it? Okay, it's right there, right on top of the black one. Both of those lines have an infinite amount of, those two lines have an infinite amount of solutions as long as it's on that line. So here we can write in infinite solutions. Okay, so that's a look at kind of like graphing to get solutions of systems of equations. But let's try and do something a little different here and look at how to find that algebraically. So I wonder if I can get this here. Let's move this out of the way over here. And I got this little one. I'm going to move it out of the way over here, and we'll go like this, coming at you from a whole bunch of different angles here. And let's just go ahead and take a look at a couple of these equations here. Let's do, yeah, here, let's try number 1, I guess. Okay, so this is using substitution to solve. All right, so let's try and put these two together. So we're looking for where the two lines cross, and we're just going to do it algebraically. So you want to make sure that one of the two equations is a y equals. Because if y equals 4x in this case, I can go and substitute that 4x to where the y is here. So let's do that. So remember, we're just looking to fill in the coordinates of a point, right? And both of these lines have two variables to it, and we want to be able to find one of them to start. So I'm going to change this equation so it's only got x's with it with something that's true. 3x minus, and here it's got y, but what does y equal? It equals 4x. Okay, and so now I've got just one variable in that equation, so I've got minus x is equal to 1, or x is equal to minus 1. And then what do you think you do? Okay, if I know what x is here, then I can go and use it to find y in either of these two equations. Remember, we're looking for the point where they cross, so it doesn't much matter which of the two equations I use here. I'm going to take that x is equal to -1, and I'm going to throw it into either of the two equations, right? So here I'm going to say y is equal to 4 times -1, substituting, the x into the proper spot. So y is equal to -4. And so that's where those two equations meet. All right, let's try another one here. Let's see what happens. Okay, in number 2, all right, this one's a little bit different because I've got x's here. Okay, so in this, still two equations, and we're looking for where they cross. So this is all equal to x, so I can throw that into the other equation right there. So 2y minus 3 is equal to 2y plus 4. Okay, so when I go to solve for y here now, check out what happens. Okay, I'm going to get these two things that, they cancel out, and I'm left with just a plain statement. And again, we look, just like last unit, we look at that statement and we ask ourselves, is this true or is it false? Okay, and in this case, no, it's false. So that means that we've got a place where I've got the same slope for those two lines and there are no solutions. Okay, and I'm going to ask you to do the next two as an exercise. But I think you can, if I had one here where it turned out to be true, okay, then that's a system where both the equations are the same lines, and you'd have an infinite amount of solutions. Right? So give that a go, and should set you up with some homework there and stuff. All right? I'll do the next video on elimination next, which will be a lot shorter. Okay? There you go.